Well, hey there, everybody. Thanks for joining us again tonight. We're inside tonight, even though it looks like it's a really lovely night outside. It's been kind of breezy, and I'm a little worried about wind gusts. We had quite a bit of wind gusts last time we did this program. So I'm just looking out the window behind me here to see what the sky is looking like, and it looks really nice out there. So whatever we do here this evening, you can take it out a little bit later anyway as the sky gets dark. So again, my name is Derrick Pitts, Chief Astronomer at the Franklin Institute Science Museum. And we're here tonight on our second installment of Night Skies at Home, part of the Franklin Institute's Franklin at Home series of science activities and programs for everybody to participate in while we're all sort of locked down under quarantine. Well, this is a kind of program that gives you an opportunity to get outside, stretch your legs a little bit, right in your own neighborhood or in your own backyard. So here's a great opportunity for you to learn a lot more about the night skies. I was reminded last week that if you're going outside into your backyard at night, maybe one of the things you want to be careful of is some little bombs that are left out in the yard by the dog, perhaps. So watch out where you set your foot. You never know what you might step into. Okay, so having said that, as just one little thing to watch out for, we can get on with observing the night sky. So we have a lot of stuff that we're going to do here tonight. I brought a number of books and other things with me, and we're going to talk about a lot of different ways that we can get engaged with the night sky. So I have all kinds of great stuff here that you can take advantage of or learn about. Okay, so let's get started with this evening's program. Actually, first of all, let's do a little bit of review about what we did last week, so that you'll be able to catch up to where we are this week if you weren't with us last week. And what we're doing in each one of these programs is providing additional material for you so that you can actually build on stuff that you learned the week before, add to it this week, and then as we provide more and more information in subsequent programs, by the time we get done with all this time indoors, you'll be pretty well versed on how to look at the night sky. You'll become sort of a neighborhood expert, if you will, about what's up there to be seen, how to see it, and what it all is. So I think that you'll have a pretty good idea of how the sky is laid out, what all the parts and pieces are of the sky, how everything relates to each other, and how the sky actually works in terms of the mechanics of the sky. Now, this is information that you'll not only be able to use this summer as we're outside more and the skies are looking better and better and it's nicer to be out, but you'll actually be able to use this information anywhere around the world. That's the really cool thing about this, is that as you become familiar with the night sky and the objects in the night sky, you'll be able to recognize them no matter where you are on the planet. So you'll be in great shape for knowing where you are no matter where you are on the planet. In addition, the information that you'll pick up here actually is also really good, the kind of information that you can use without a telescope. You don't need binoculars, you don't need anything like that, no equipment, although we will talk about equipment in some of the next programs. It's just that in these first programs, and really throughout the program, I'm going to be pointing toward information that's useful by anyone of any age, no matter what your skill level, okay? And also, no matter where you are. So it doesn't matter if you're in Center City or if you're out in the country someplace, all of the information that you're going to pick up here will be useful no matter what the application. Okay, it's also great for kids that are learning the sky because there are a lot of cool games you can play with astronomy. There's a big connect the dots game you can play with astronomy. There's a big, sort of like draw your own constellation, if you will, name your own constellation, pick anything you like in that manner so that the sky really becomes yours to own, in fact. So there's a lot of that sort of stuff. And as I said, hopefully out of this, you'll become a regular sky watcher. Okay, so let's go on to what we talked about last week just to cover those bases. Last week, as we began, we talked about cardinal point directions. How do you figure out your way around the sky? And we talked about ways in which you could figure out your cardinal point directions. The simplest way for me to describe it for you here, as we're sitting inside my big local observatory, one of the ways that you can do this is very simple. You can actually look toward the portion of the sky where you see the sun setting. Over on that side of the sky where you still see illumination from the sun in the evening, that's the direction west. So if you were to face west, that's a good way to get started because now you're facing west. And here's how you find the other directions. If you're facing west, just make a quarter turn to your left. Quarter turn to your left, you'll be facing south, okay? So here you are now facing south. Over on your right-hand side is west, okay? Now we're going to make another quarter turn from south. We're going to make that quarter turn to the left. And that's going to have you facing east. Now what you have is east directly ahead of you. You have south on your right. And guess what? Very cool thing has now happened. You've now put together the directions for where the sun rises and where the sun sets. Because the sun rises in the east, passes through the south during the day, and then sets in the west. So now you have 3 of the 4 directions. The only one that's left is the north. And so as you're facing east, one more quarter turn will bring you to north. Now you're completed. You have north, east, south, and west. East is where the sun rises in the morning. West is where the sun sets in the evening. South is where you find the sun at noon during the day, high in the middle of the sky. And then opposite noon is where north is. So here's a cool thing you can do with this. Go outside around noontime, around lunchtime for you, somewhere in that period of time. Identify the direction of the sky where you see the sun. Okay? Now, if you're facing in that direction, by the way, don't look at the sun. Don't look at the sun. Don't look at the sun directly unless you have the proper eye protection for that. And that means you need those solar eclipse filters from 3 years ago that you used, okay? Well, I just want you to be outside facing the direction of the sun. Well, now that means directly behind you is north. That's north. So if you're ever wondering which direction is north, figure out where the sun is in the sky at noon around lunchtime. The opposite direction is generally north, okay? So you'll be in good shape. Excellent. Now, here's another little piece that can go along with this. If you want to transport this information, if you want to use this kind of context at night when the sky is dark and there's no sun to work with, very simple. Look again toward the west. As you're looking over toward the west, what physical objects are out there? Is there a house? Is there a building? Is there a tree? Is there a parking lot? Is there a market? Is there something out there that's always going to be there? Well, that building that you see over there in that direction where the sun's setting, that building is going to be there at night. So, if you want to figure out your direction at night, when it's dark in your neighborhood, just see where that building is. Look toward the direction of that building, you've got west. Quarter turn to your left, you have south. Now you have east on your left, west on your right, south directly ahead of you. You're all set up for now how the sky works overhead, because the sky just kind of passes overhead from east through south to west. Okay? So now we're cool on directions. We did that last week just to get everybody caught up. Okay, so now we talked about sunrise and sunset on the east and on the west. One thing we need to add to this now is that as we're moving through spring on into the rest of the year, headed toward the summer solstice, you know what's going to happen? The sunrise and sunset times are going to change. So we've been starting this program at 7:45 in the evening, thereabouts. But what's going to happen is as we move further into spring, the sunset times are going to come later and later and later. So one thing we have to be aware of is that even though it might be just dark enough right now for observing, guess what? As we move further on, the sunset time comes later. That means you'll have to start your observing even later in the evening. Now, the latest the sun sets in this portion of the world, 40 degrees north latitude, 40 degrees north of the equator, anywhere around the planet, okay? The latest the sun sets is about 8:34 in the evening, and that's right around the summer solstice, right around June 21st, okay? But the sky doesn't get dark for another half hour after that because of this effect called twilight. That's the period of time between when the sun drops below the horizon and when the sky actually gets dark. So after about half an hour, the sky will actually be almost dark, okay? So you'll have to add that onto your time. So in the deep summer, while the sun sets at 8:34, you might have to wait until 9 p.m. or 9:15 to actually begin some observing. All right? Well, don't worry about that because as it turns out, guess what? there are some objects that you can see even during twilight, okay? And the objects that you can see during twilight are the first objects that appear in the evening sky. They're always the brightest objects that show up first, and there's a sequence to this. Just go by what you think of as the brightest objects. What do you think the brightest objects in the sky might be? Well, let's start first with the moon. That's the first one. After the moon come the bright planets. Those will be the next objects you see in the evening sky. Then after that, the bright stars. And then after the bright stars, of course, the dimmer stars. So if you're out in the evening right now, you'll see that brilliant object high in the western sky. That bright object is the planet Venus. That's Venus. You've probably already seen it. You might have already guessed what it is. Well, that's one of the brightest planets, the brightest planet we can see in the evening sky. So as you're looking at that bright object that you think is a star, it's actually a planet. Okay, now we have a question. So let's see who this question is coming from. I'm going to turn to my crack production crew here, and we'll see what the question is.
Will we be able to see Comet Atlas in May, or is falling apart and fading out? And when will bright Venus be the brightest?
Ah, that's a great question. Two great questions. When will Venus be at its brightest? And when will Comet Atlas be visible to us in May? Okay, so let's take the Venus part first. So Venus is getting really, really bright right now. And part of the reason why it's getting bright is because there's a lot of surface to reflect light from as we're seeing Venus from Earth. As Venus continues in its orbit, what's going to happen is it's going to reach its peak brightness pretty soon, and then the brightness is going to start to drop off as it continues in its orbital path around the sun, and less of its surface is actually turned towards Earth. So we have a while now when we can watch Venus being very, very bright. It's really bright right now. That brightness is going to decrease as we head towards summer, but it's not going to drop off so far that you won't notice it at all, okay? So it'll stay nice and bright. You'll always be able to identify it. Here's the other thing about this. You know, when you get used to seeing what Venus looks like in the evening sky, when you get used to it, you'll never mistake it for anything else ever again. So how do you become so familiar? It's pretty simple. Just go out every evening the sky is clear. Take just a minute to look at the sky and see what Venus looks like. After a few days, you'll be so used to what it looks like that you'll be able to recognize it anytime it's in the sky. All right, so let's go on to Comet Atlas. Comet Atlas is an object that is moving around our solar system. It will, let me do it this way, hopefully, Comet Atlas will remain intact enough that by the time it's supposed to become easy for us to see in the sky, it will still have enough material pulled together to reflect enough light from the sun for us to see it really well in the evening. So that's going to be coming around in May. Right now, though, it seems to be undergoing a change, and that is that the nucleus of the comet, the frozen icy ball of the comet that is reflecting light from the sun, has broken up, and maybe it's beginning to elongate itself out a little bit as the particles break up. Well, we'll take a look at that a little bit closer next week, and then when we get to May, hopefully we'll be able to see a bit more of this comet. We have another question.
Will we get to see something in 30 minutes? And with the quarantine causing less pollution, will the night sky be brighter? And what types of eclipses are there?
Oh, that's a great question. So,
30 minutes.
What will we be able to see in the sky in 30 minutes? Well, of course, Venus will be up in the evening sky. The moon is rising a little bit later tonight, so you'll be able to see that as well. And of course, the bright stars of this particular season are going to become available in about 30 minutes as the sky gets dark. Unfortunately, no International Space Station tonight. International Space Station is on a cycle of orbits that now has it flying over Philadelphia either mostly during the day when we can't see it, or deep in the night when we can't see it. So we'll have to wait for a couple of weeks before it re-emerges in a sky where we can see it, and that emergence is going to be in the pre-dawn sky. So April 25th, I think, is the next date coming up when we'll be able to see International Space Station, but it will be in the morning sky. Then there'll be a little bit of a change until it shifts over into the evening again, so it's into May before we get to see it in the evening sky again. Okay. So now, what was the last part of that question?
Eclipses, and when will all the planets align, and what will happen, and what type of eclipses are there? Eclipses.
Sure, eclipses. Well, there's all kinds of, let's do it this way. We can have eclipses of the sun. We can have eclipses of the moon. We, unfortunately, don't have any eclipses that will be visible to us this year. In fact, I'll have to check and make sure about the lunar eclipses. I don't have that information right off the top of my head right now, but I know we have no solar eclipses in this portion of the world for a little bit. In fact, the next one that's really available in this part of the world is, let me see, April 8th, 2024. That's when the next total solar eclipse is in the continental United States that we'll be able to see as a partial eclipse from this portion of the country. If you want to go see the totality of the eclipse, you'll have to go out to a path that runs right up the middle of the country from the south near Texas all the way up into western New York State and on up into New England. So we can talk about those a little bit later too as we get some of this together. So let me tell you where you can find some of this information that we might talk about in the evening sky. Oh, let me do it this way. Some of the things that we want to learn about in the evening sky are the constellations. We always want to understand what patterns we see in the sky. What are those constellations? How do we identify constellations in the sky? Well, it's not difficult. It's just that you can't try to do it all at once. So, you know, when you go to a bookstore or you go online and you find some book someplace that's going to tell you everything you need to know about the evening sky, you might come across something like this. A nice big book that has lots of information in it, has great star maps and all this kind of cool stuff. You can see what these look like. Yeah, right. And you might think that you're going to try to learn all of this, not in one sitting, but you're going to try and learn as much of it as you can, so when you go outside, you're all set and ready to go. Well, that's one type of book you might use. But here's my recommendation for how you actually should do this. The way you really should do this is learn one constellation at a time. Take one constellation per evening. And how do you get started with the one constellation? Well, you pick the bright constellation. That's the main constellation of the sky for that season. And we actually have two of them right now because here in early April, we have two main constellations. As the sky gets dark, hanging over high in the southwestern sky, we find what was the main constellation of the winter sky, and that's Orion the Hunter. Now, we talked about Orion last week. This is an object that looks like it has three stars across the belt. A star for this shoulder, a star for this shoulder, a star for the knee, and a star for the ankle. And we can actually get the idea of this figure standing up in the sky, Orion the Hunter. Well, that's the main one for the winter constellation. Now, if you wanted to learn about Orion, here's what you might do. You might go out, and I'm going to show you one particular map that I think will help you really understand how this works a little bit. I'm going to hold it up like this, and I'm going to show it to you, just like this. Okay? Now, right in the center here, we can see Orion the Hunter. 7 stars, 3 at the waist, and 2 stars at the top, 2 stars at the bottom for the shoulders and the ankle. Now, you'll notice that there are other constellations around Orion. So here's what I'm going to recommend you do. You see that shape of Orion? Well, here's what you do with the shape of Orion. With your star map, what you want to do is look at that particular shape and understand how the shape is structured. Where are the stars? What are they shaped like? What does that pattern for that one constellation look like? And then, in the evening, go outside, find that one constellation, make sure you're seeing the right one because you've identified that particular pattern, and now you can reward yourself because you've identified your first constellation. No matter what your reward is, maybe it's a glass of wine, maybe it's a popsicle, maybe it's a piece of pizza, maybe it's chocolate, whatever it is that turns you on, well, that's what your reward is going to be. Now, the next night, what you're going to do is you're going to use that same constellation, but you're going to pick a constellation that's adjacent to the one that you first learned. And you'll go back outside, and what you'll do is you'll first identify your main constellation, and then look for the new one that you've selected adjacent to it. Now, if you just do this night after night after clear night, then that way you can learn 7 constellations in 7 observations. Now, here we are in Center City, Philadelphia, many of us in Center City, Philadelphia. If you live in an urban area, you're going to be challenged to find a lot of constellations to begin with just because of the city light conditions. Well, guess what? 10 constellations are what you need to find your way around a sky. Now, in fact, we can make that even shorter. We can cut that list even more. 7 constellations will be enough to get you around the sky for any particular season you're interested in. Now, what's 7 times 4? That's 7 constellations per season, 4 seasons per year. That's 28 constellations all year long. And you can learn 28 constellations, especially if you do it at the slow rate of 1 constellation per night, added on from night to night. Not so bad. But if you do this every night the sky is clear, and I mean just take a couple of minutes. This is not 2 hours of observing. This is not freezing yourself to death. This is just step outside, take your family with you, look up at the evening sky, identify the major parts and pieces, take about 5 minutes to 7 minutes, and then when you're done, reward yourself. Now, of course, as you get into this more and more, you're going to want to spend more time outside because you become so familiar with it. Okay, so you can do that, and that's not a bad thing at all. It's an easy way to do that. We have a question.
Rachel says, my daughter wants to know how stars are made.
Wow. Rachel, you have to tell your daughter that is a whole astronomy course in and of itself. That's a really big question and a really fun question. But I'll give you a little bit of aspect about that will help you a little bit along the way. And Rachel, it'll give you something to do with your daughter while you're outside in your backyard. You can see if you can catch some of this as you're viewing. Here's what I'm going to give you to do. I'm going to ask you to go outside. When you go outside, look around to see if any of the stars have color. See if any of the stars have color. You'll find that some stars are white, some stars are bluish, some stars are orangish, okay? Maybe a little bit of red, a heavier orange tint, but those are the colors that you'll find. In fact, star colors actually run this gamut. They go from red to orange to yellow to white to bluish. Now, you won't find a star that's the color of the blue sky of the day. What you'll find is you'll find a star that looks a little more blue than a white star does. Now, one of the things that's happening with this is, you're actually seeing the temperatures of the stars as provided in colors, okay? So the colors of the stars actually tell you what the temperatures of the stars are. And here's a little piece that goes along with that. I'll bet you're guessing that the hottest stars are the red stars. Nope. In astronomy, it goes the other way around. It turns out that the hottest stars are the ones that are bluer in color, and the very coolest stars are the orange and the red ones. There are actually stars called brown dwarf stars that are even deeper in color than the reds that don't put out enough energy for them to glow really brightly. So that's one way you might do that. Let me see if I can find an image here, and I'll show you one really quickly of what one of these stars looks like. Now, you might be saying to yourself, gee, you should have had that book open before, right? Yes, you're right, I probably should have, but I'm going to take a quick peek here and see if I can come across it really quickly. Oh, yes, here we are. Right, here's an image I can show you. Now, don't pay much attention to the complexity of the image. I just want you to see the star colors here. We can talk about all this other complicated stuff later, but you'll see that the stars can go from blue to white to yellow to orange to red. Now let's put our own star in the context here. If we put our own star in the context here, our star, the sun, guess what? Our star is a yellowish white star. Yellowish white star. Okay? So we're right in the middle of the color temperature range. We're not too hot. We're not too cold. Turns out we're just right. Now, Just right is what's just right for us when we talk about the Earth being at the right distance from this particular star for us to live here on this planet. So there's a little bit for you, Rachel. You've got a little bit of an assignment to do. You can go outside, look at the stars, see if you can identify any colors. And if you can, you'll have an idea of what those temperatures are. We have another question.
Is lightning really hotter than the sun? And Cal would like to know, when will the next meteor shower happen?
Oh, two great questions. Okay, is lightning really hotter than the sun? Well, as it turns out, the surface of the sun, our particular star, the surface of our particular star is about 12,000 degrees Fahrenheit. And boy, that's hot. But a lightning bolt is even hotter. A lightning bolt is 50,000 degrees. But now we're comparing the surface of the sun to a lightning bolt. If we were to dig down inside our star and go down to the core of our star, well, we find that the temperature there is millions of degrees. Millions of degrees. So if we're looking at the surface, yes, that's true. But if we dig down inside our star, well, we find things a little bit different. There are stars that are much hotter than our sun. We can talk about those later. But let's get on to the next question, which is, when's the next meteor shower coming up? There are about 14 meteor showers during the course of the year. The major ones that we can actually see without any difficulty are the Geminid meteor shower in December and the Perseid meteor shower in August. Now, there are some other meteor showers that happen in between, but they're not the most prominent meteor showers. We'll come to those also as the next one comes up for us in the next month or so that might possibly have some members that are visible. But remember this, anytime you're outside under the evening sky, there are always meteors falling into the Earth's atmosphere. Now, meteors are just small chunks of space rock, and they're not very big at all. In fact, these meteors are only about the size of sand grains. Can you believe it? Only the size of sand grains. But the energy with which they come into the Earth's atmosphere causes the air around them to glow really bright with heat as they punch their way in, and that makes the bright streak that we see that we sometimes call a falling star or a shooting star. Now, stars don't fall and stars don't shoot, but these little tiny bits of rock falling into the Earth's atmosphere do. On any clear night, you can see 10 meteors falling into the Earth's atmosphere per hour. On any clear night, you can see about 10 meteors per hour. So if you're outside under the evening sky, just out there enjoying the evening, you might be able to see one or two bright streaks as they come through. Okay? All right, so now, the next thing I need to do here is I need to show you just some different examples of ways in which you can learn about the night sky and identify constellations. Here's one way to do it. This is a book called 365 Starry Nights. This particular book actually walks you through almost every night of the year and gives you a little bit to think about and look for in the evening sky according to the constellations that are available. That's pretty cool. It's written by a really wonderful author by the name of Chet Raymo. Chet Raymo, R-A-Y-M-O. And I think this is a really cool book because it gives you a lot of background information about the constellations themselves and about each of the stars or many of the bright stars that you might see in the sky. So that's one really cool one you can do. Another one you can do is you can do something like this. Here's a small handheld sky guide. This one is laminated. You can see what it looks like here, just like this. And the cool thing about this is that this actually folds out like this. And as it folds out like this, it gives you the sky for different seasons. So right now, I have this one set up for my production assistant can see which season we're looking at here.
Spring.
We're looking at springtime. And you can see this is a really cool guide that you can carry out into the field with you. And it shows you the main constellations. It doesn't show you every constellation, but it shows you the brightest ones that you might be able to see and identify so you can find your way around the sky. So you can see on this side it's spring, summer, and then if we flip it around to the back side here, you'll see there's fall and winter over here. And then there's also a guide for the moon as well to help you identify some features on the moon. So that's a pretty cool one that you might be able to find. And this is just an example of what you might be able to find that might work for you. Another one that you might be familiar with is this one. This is the round one called the Planisphere. The Planisphere. Now this one's really cool because what it does is it allows you to identify what patterns are available in the night sky at almost any time of the year. But this one's a little small. Now, you know, a guy like me, cool astronomer, you know, I have to have a really serious one, right? So, rather than having something tiny like this, I'm going to use something like this. Now, here's the reason why I'm using this, though. The reason why I want to use this one is because it's easier for me to show you the various parts and pieces of how this works, okay? So, with this kind of star map, out on the outer ring, you have the dates and the times of observing. And the way this works really simply is, all you do is you just align the date with the time. So if you look right at the bottom here, what you can see is I can rotate this window around, and I'm going to align the time 9 p.m. here with this April date. And let's see, where are we? We're at April the 9th. So now here we are. I've lined this up, so it's April the 9th at 9 p.m. And in this window right here are all of the stars that are visible for this time and this date. Now I can adjust this. I can keep the date and I can change the time if I need to. And I can make it 10 p.m. or 11 p.m. or midnight. And guess what else I can do? I can use this for any date, any time during the course of the year, and it will show me what stars are available. Now the really coolest thing about this is good for about 12,000 years. And that's because the stars don't change their position all that much very quickly. So this is good for a really long time. You know, if I had one of these and I sold it to you, I'd tell you that it's good for 12,000 years. And if you have a problem, if you bring it back at the end of 12,000 years, I'll give you another one. Okay? All right, great. Okay, a couple more here that I really like. This is an oldie but a goodie, the Edmund Mag 5 Star Atlas. This one is really cool, and I'll tell you the reason why. I like this one a lot because what it does is it shows you the sky like this. Now, you might say, hey, wait a minute. Why can't I have that in color? Couldn't I have that in color rather than black and white? Yeah, you could, but guess what? This large format makes it easy for you to identify the star patterns that you want to work with, and then lets you translate that out into the night sky. So I like these big ones like this. But guess what? There's so many different kinds available on the market. You can pick and choose what you think works best for you. Okay?
Upside down.
Oh, sorry, upside down. My production assistant says. There we go. Okay.
Question.
So you can pick and choose whatever you like that you might think will work best for you. Now, there's one other last piece about these that work really well. And that last piece that works really well, let me see if I can get this to work for you. I'm almost positive I can. Here's one of my favorites. This is a home planetarium system that I'm running on an iPad called Stellarium. Now, what Stellarium allows me to do is I can look at the sky for any time of the day or night on my iPad. And there are a number of these as well. There's Orbit Track, Satellite Safari, Pocket Universe, all sorts of different apps that you can get for your smartphone that will show you the sky anywhere on the planet, any time of day or night, give you the star patterns, the constellation names, everything you need, and help you find satellites as well. Now you might say to me, which one of these is the best one? Well, it turns out that they all do the same thing. But here's my secret. I like the free ones. I like the free ones. And I like the free ones because they work really well and they don't cost anything. And Stellarium is particularly good, but it's free. And it works on your tablet, it works on your phone, it works on your desktop, it works on your laptop. So that's a suggestion that I would recommend for you. We have a question. Let's go back to that question. Yes?
Quite a few. Josh ponders, what is the biggest star? Is it Betelgeuse? And how is the sun made?
Wow. Josh, those are two big questions. Is Betelgeuse the largest star? Betelgeuse is what's known as a red giant star, but it's not the biggest star. There are some stars that are really, really, really enormous. There are stars that make our star, the sun, look as if it's just a speck of sand. If I were to try to remember the numbers off the top of my head, I would be hard-pressed to do that. But there are stars that are hundreds of times bigger than our star. So Betelgeuse is not the biggest. It just turns out to be what we call a red giant. Now that term is a class that's used. It's a way to describe a particular type of star. That astronomers use that term, red giant, to indicate a stage of life for the star. So yes, it is bigger than our star. We could think of it as being a giant compared to our star, but in reality, even Betelgeuse as a red giant is rather small compared to some of the biggest stars there are. Now, what was the question again? How do stars work?
How is the sun made?
How is the sun made? Oh, that's another astronomy class for you, but let's just shrink it into the smallest possible space we can. And that is, if you take a gigantic gas cloud of hydrogen gas and you squeeze it down until the temperature and pressure in the core of that cloud of hydrogen gas gets the hydrogen nuclei close enough, what will happen is they'll interact with each other in such a way as to produce a process called fusion. And that fusion process, when the nuclei combine, will create energy. And essentially what's happening at the core of stars is that there is an ever cascading event of nuclear fusion that's happening at the core, where hydrogen nuclei are fusing together and through a chain reaction continuing to produce energy. And that's the energy we see coming from our sun. That's where all the light, that's where all the heat comes from, is from this fusion process. Now I've given you the really simple explanation, and it can get really complicated. We got a few more things that we have to do here before we close out for the evening. So let me just continue with a little bit more of this, because you know what? You need to know what you can see in the evening sky coming up for this week. So, as we talked about earlier, Venus is in the evening sky. You can see that without any difficulty at all. Very bright, clear white color, nice steady glow. And also, the moon is hanging up there as well right now in the evening sky, rising rather late, but you can still catch that. Now, next week though, Wednesday, Thursday, Friday of next week, here's something I wanted to mention, is that the moon is going to be sliding past those 3 bright planets in the morning sky. Now, this is the other thing. Venus is in the evening after sunset. In the morning before sunrise over on the eastern side, anywhere from 4 o'clock in the morning until around 5:45. You don't have to get up at 4 a.m. You don't have to do that. But if you get up around 5:30 and catch this, you'll be rewarded well, because those 3 planets are 2 of the biggest planets in the solar system. Jupiter is the brightest one of the 3 that you'll see in the east. They're arranged in a line, by the way, so you'll see Jupiter. And then to the left of Jupiter, you'll see the ringed planet Saturn. And then a little bit further to the left, you'll see the rosy-colored Mars, all stretched in a line across the sky. Not very far apart at all kind of together, actually. Well, what's going to happen is the moon is going to slide past each of those planets next Wednesday, Thursday, Friday morning. So I want you to be able to see that. If you can take a minute to just, if you're out in the morning early with the dog, if you happen to wake up early, you can't sleep, this is worth a look at the skies clear, because you really want to see how those planets slide by. Okay, we have one last question.
We have to take this question from adorable Everett, who's 3 years old, and he would like to know how the moon floats in the sky.
Oh, that's a really cute question, Everett. Thank you so much for asking that question. The moon is really cool to look at. Everybody loves to look at the moon. And you might wonder, how is it that the moon can actually just hang up there in the sky? Well, actually, what's happening, Everett, is that the moon orbits around the Earth in a circular path around the Earth. And the reason why it can do that is because the moon actually has what's called a velocity. It has a speed at which it moves, and it has a direction. Those 2 together, we call that velocity. Well, guess what? There's also the gravitational pull of the Earth. And so what we have is we have a balance. The gravitational pull of the Earth and the velocity of the moon. The moon wants to go out, but the Earth's gravity pulls it in. So what happens is there's a tug of war between the 2, and there's a balance. And the balance of the gravity of the Earth pulling and the moon's velocity wanting to go outward creates the circular orbit that goes around the Earth. And that orbit we see as we look at the moon as its position changes every day. So if you were to go outside and look at the moon tonight at one time, and then go out tomorrow night at the same time, you'll find that the moon has moved on. And that's because it has moved along in its orbit with this velocity and the gravitational pull. So now, when you go out to look at those planets in the morning, here's one thing I want you to consider. I want you to think about their three-dimensional placement in the sky. And here's how you can do it. It's really simple. Just think about the distances between the planets. Now, I'm going to give you the numbers, but you don't have to remember them, all right? Let's go. Jupiter. Jupiter's distance right now is 473,927,151 million miles away right now tonight, okay? Saturn. Saturn is 936 million miles. 936 million miles. 683,978 million miles away. And finally, Mars. Mars is the closest of the three. It's only 125,546,705 miles away. Okay? Now, let's get rid of the numbers and just give you this piece so you understand it. Mars is 48 million miles away from Earth. From Earth. Mars is 48 million miles away from Earth. Okay? Now, the distances I gave you before, those are the distances from the Sun. Okay? So now we're going to do from Earth. Mars is 48 million miles away from Earth. Jupiter is 391 million miles away from Earth. That's 8 times farther away than Mars. So when you go outside and you see Mars and you see Jupiter, the big bright one, just think that Jupiter is 8 times further away from us than Mars is. Now let's put the cap on this. Saturn. Saturn is 797 million miles away from Earth. That's 16 times farther away from Mars. So from Earth to Mars, and then 8 times farther away from Earth is Jupiter, and then Saturn is twice that far away, 16 times further away. So now as you're looking at them, it's going to look like this. Mars is going to be the closest one. Jupiter is going to be the next closest one. And then Saturn is way out there, way out there. So the two on either side are the closer ones, and the one in the middle is way, way out. And that's the reason why Saturn looks so small. Now, if you stare at this for just a minute and think about those distances, you know what's going to happen? Especially if you're out there with the moon. This is suddenly going to pop into 3 dimensions for you. And you'll suddenly go, whoa! Now I see the scale of the solar system. So if you do it with the moon, you have the moon really close, then Mars, then Jupiter, then Saturn way out there. And you will have completed a great evening of observing or a great morning of observing. Okay, so we've come to the end of our program. There's so much that you can get out to see if you're out in the evening sky. Remember, you have Venus in the west after sunset. You've got the bright planets in the morning before sunrise. And remember, if you're going to learn about the constellations, well, the way to do it is take one constellation at a time. Okay? So next time, we're going to go, or next week, I should say, we're going to do star brightnesses and colors, and we'll talk a little bit more about constellations, and we'll start to talk about how you might be able to use observing equipment to look at the sky. We'll start first with binoculars. Okay, so I want to say thank you very much for joining us tonight. Thank you for the great questions. I really do appreciate it. You need just a few minutes each day to keep up with the night sky, and I'm sure you can do that. It'll give you a chance to get outside, stretch your legs. And remember, this is something that you can do with everybody in your family, and you can even do it with your extended family across town. You can have a star party with the rest of your family spread around the region if you invite them to go out and look at the sky with you. So again, like I said, next week we'll talk about star brightnesses, colors, how to use binoculars to observe the sky, and a little bit more about the main constellations you can see in the sky for this season. Okay, thanks for joining us. Stay safe. We really appreciate you joining us. And don't forget, go to the Franklin Institute's website and check out Franklin at Home. You'll be able to find all kinds of activities that you can do all across the board of different disciplines in science that you'll find interesting and exciting. So again, thanks for joining us. We'll see you again next week. Best wishes for clear skies.